Good morning, students. We are continuing the topic. Next is the types of acceleration. We have positive acceleration and negative acceleration. Now, here we can learn positive acceleration by example. We know the formula of acceleration is a equal to v minus u upon t. If suppose the initial velocity u it is 20 meter per second and final velocity is 50 meter per second and time it is 5 second, when you will put the value 50 minus 20 upon 5, you will get 30 upon 5. When you will solve it, you will get 6 meter per second square. Since the answer is coming in the positive, we can see that it is a positive acceleration. In the second case, if we know when the initial velocity it is higher than final velocity. Here the initial velocity it is 100 meter per second and final velocity it is 60 meter per second. And time is 4 seconds. Now we know that the formula of the acceleration it is v minus u upon t. When you will substitute the value, you will get 60 minus 100 divided by 4. Since we are getting answer minus 10 meter per second square, so here we can consider that it is a negative acceleration. Now this is the graphical representation of motion, that is the distance time graph and a velocity time graph. Now for the uniform speed or the velocity, and you will see that it is a straight line, while for the non-uniforms it is a curved line. Now velocity diagram for the uniform motion and uniform accelerated motion. If you see the first graph uniform motion, there is the acceleration, it means it is not changing, it is under the constant value, so it is a straight line. But in the case of uniform accelerated motion, continuously the body, the velocity it is goes on increasing, so we are getting a uniform acceleration motion and it is shown by a straight line in the graph. Now next, if you see the equation of motion, there are three equation of motion: v equal to u plus at, vs equal to ut plus half at square, and v square minus u square equal to 2as. These are three equations of the motion. Now depending upon the different situation in the numerical, we will be using these equations. Now next we are deriving this equation by a graphical method. Now first, if you will see the equation of velocity time relation, the graph it is given, the body it is moving from OABDC. Okay, now we'll derive first equation by the graphical method. If you see the slope it is equivalent to the acceleration. Okay, so we can write slope as AB equal to BD upon AD. Now here BC is equivalent to BD plus CD. Now if we want to find out BD, we can write BC minus CD. Now slope equal to change in the acceleration upon time. Here AB is representing A and the change in the acceleration is the V minus U upon T. When you will cross multiply, you will get AT equal to V minus U, and when you will shift U there, you will get finally V equal to U plus AT. So like this we are deriving the first equation of motion, that is V equal to U plus AT. Now next, if you see the second equation, that is the S equal to ut plus half at square, the same graph we will be considering, but here to find out the distance S, we have to use two formula, that is area of rectangle and area of triangle ADB. Now we know that area of rectangle is length into breadth. Here we'll see that it is OC into OA, and half into base into altitude, half into AD into BD. Now here we have to substitute the value of BD. Now we know that BC is equal to BD plus CD. Now if we want to find out the value of BD, we will get BC minus CD, and BC minus CD it is equivalent to V minus U, and BD it is equivalent to AT. So when you will substitute this value, you will get S equal to, in place of OC you will write T, OA you will write U plus half T into V minus U. So finally we'll get S equal to UT plus half T V minus U. Now in this equation we have written this V minus U is equivalent to AT. So in place of V minus U, you will write AT. So last you will get S equal to UT plus half A, and T will be multiplied to T, will get T square, S equal to UT plus half AT square. This is the second equation of motion. Now next we are deriving the last equation, that is V square minus U square equal to 2AS. Now here area under the slope is equivalent to displacement, that is area of triangle OABC. Now area of trapezium, now this is OABC, it is a trapezium, and we know the formula of trapezium, half into sum of parallel sides into height. When you will write half into sum of parallel side, here it is BC plus OA into OC. So when you will substitute the values, we'll get half into V plus U into T. Now we know from the first equation that V equal to U plus AT, or we can write T equal to V minus U upon A. This value of T will substitute in this equation, half plus V plus U into, in place of T we will write V minus U upon A. Now you will get S equal to V plus U, V minus U upon 2A. Now in the mass we are using the formula A plus B, A minus B is equivalent to A square minus B square. So in the place of V plus U and V minus U, you will write V square minus U square, and we will multiply 2A into S, you will get 2S equal to V square minus U square. So like this we'll derive all the three equations of motion. The first one, it is V equal to U plus AT. Second one is equal to S equal to UT plus half it is square, and third it is V square minus U square equal to 2A S. Now under the different situation in the numerical, we will be using this equation if as per the given condition, if suppose distance is not there, we have to calculate A and T, we will use first equation, and whenever we have to calculate the distance and along with that time and the other things are given, we will be using second and the third equation.